Hello, I'm Dr. Deepthi and we are studying different concepts from maths, namely under the heading Decreations Mathematics, and we have been looking at topics from linear algebra. Now, we have been considering the topic of matrices. So, in the earlier episodes, we first looked at what a matrix is. So, we now know that it's an array of elements constitutes of rows and columns. So, here there are m rows and n columns. We understood the meaning of a matrix, what is its use, not only in mathematics but also in daily life, etc. So then we moved on to check the algebraic operations of matrices, namely addition, subtraction, and scalar multiplication. So if you want to revise that, you can look at the previous episodes. Now today we are going to talk about matrix multiplication. So in scalar multiplication, it was easy. There was just one entry and you multiplied it with every element of the matrix and got the matrix there. Now here we are going to look at multiplication of two matrices. For that you should understand the concept of dot product. Hopefully you are already well versed with that, but just to refresh your memory, dot product of two n tuples is taken and basically the length has to be equal. Now what do I mean by n tuples? So if n is equal to 2, then it's a 2 tuple, and if you see here, there are two entries, so it is called 2 tuple. So 1, 2. Similarly, you have another 2 tuple. Now since the length is equal, dot product can be taken. And how is it taken? It is basically product of corresponding entries and addition of all those products. That gives you a single number. To illustrate it, if you multiply this tuple 1, 2 with 5, 4, then you have to multiply the respective entries 1 into 5 and 2 into 4 and add it. So 5 plus 8 is 13. Now, when you go for matrix multiplication, of course we know it's a product of two matrices. Each matrix row and column is considered as a n tuple. And there is one condition that is very important. Number of columns of first matrix has to be equal to number of rows of second matrix. Why is it? Because every entry in the product matrix comes from the dot product of a row in first matrix and a column in second matrix. And we will be able to take the dot product only if this condition is satisfied. That is, the number of columns of first matrix is equal to number of rows of second matrix. Now let us illustrate it further. So there are two matrices. First matrix, you can call it matrix A if you want to. It consists of m rows and p columns. And another matrix which consists of p rows and n columns. So what was the condition? Necessary condition? Number of columns of first matrix have to be equal to number of rows of second matrix. So here number of columns of first matrix is P and number of rows of second matrix is P. That means that condition is satisfied. So a product can be taken. Now how is the product taken? It's a dot product. So you have to take entry from the row. That means, for example, let us consider the first row and first column. So A11, that has to be multiplied with B11, which is the first entry from the first column. That gives you the term A11, B11. Similarly, if you take the entry A12, which is the entry from first row, but it is the second entry, you will multiply it with B21. The second entry from first column. Similarly, you will get A13, B31, etc. up to the last product, which is A1P into BP1. And when you add all these, you are going to get the first entry. See, this is just the step done to get one of the entries. You have to repeat this procedure for getting all the entries. For example, if you want to get C21, you have to multiply the second row of first matrix with the second column of second matrix. In this manner, when you want to get this particular entry, CMN, you have to multiply mth row of first matrix with nth column of second matrix. And understand that if the order of the first matrix is, for example, here it is m into p, that means m rows, p columns. Or in this case, it is p into n. So, the order of the resultant matrix will be m into n. Can you see it here? Now the same thing is represented in this notation. So do not get scared by this summation notation. What are we trying to do? We are just trying to do this exercise for every entry Cij, where you know that it belongs to this matrix of the order m into n. So I, number of rows go up to m, and j, number of columns go up to n. For example, if you consider C11, when you say C11, we have already fixed the value of I to be 1 and j to be 1. So, in order to understand this particular expression, how it arises from this summation notation, look here. So, I has already been fixed to be 1 and j has already been fixed to be 1. First entry will be for k is equal to 1. So, A11 into B11. Isn't it the same? Similarly, second entry will be for k is equal to 2. So, A12 into B21. Isn't it the same again? So, in this manner, go on doing it for all the terms. Last value is for k is equal to p. I and j we have already fixed to be 1. So, no need to worry about that. So, what will be this term? A1P into BP1. So, in many a times in different books, they simply give this summation notation and then students get confused. So, here we have tried to understand what this notation exactly means. So, this gives you one entry. Similarly, you go on calculating all the entries and get the final product matrix. Let us try to take some numerical values. This same expression has been written, what we have looked at right now. Now, one matrix is given to you, which is matrix A, which has the entries 1, 2, 3, 4, and matrix B has the entries 5, 6, 0, minus 2. Now, when you are multiplying, consider row 1 and column 1 and multiply respective entries. So, 1 into 5, which is 5, plus 2 into 0, which is 0. Similarly, when you want to get this particular entry, you have to consider 1 into 6 plus 2 into minus 2, which is 6 minus 4. Again here, 3 into 5 plus 4 into 0. So 3 into 5 is 15, 4 into 0 is 0. So this expression. And last one, 3 into 6, which is 18, plus 4 into minus 2, which is minus 8. So if you evaluate it further, 5 plus 0 will give you 5, 6 minus 4 gives you 2, 15 plus 0 gives you 15, and 18 minus 8 gives you 10. So we have been using this same logic. So try to practice it. In the next episode, we will try to check whether matrix multiplication is always commutative. And of course, let me give you the answer. No. Answer is no for that. It is not. So we will check that and move further. Thank you.